Hey everyone, welcome to my channel. So let me share my screen. So we are at structured streaming. Currently, we are at structured streaming. So yeah, let's. So as of now, what are all the concepts we have covered? I think let's review in a quick span and. Mm, Structure streaming is like an next phase, like it's a when you wanna when you wanna process the data continuously. So for that purpose, the structured streaming is created in Spark. So for example, live data and all those other stuff you need to perform banking transactions that should not have any breakage in between. So for those kind of things, I mean, it will be, I mean, you need to immediately perform those operations and generate the results. So that is the main purpose of the structured streaming main usage. I mean, let me go further. So we'll start the first. Okay, what is structured streaming? Process continuous incoming data. Yeah, so that's what I said just now. Continuous incoming data uh, using the same data frame style API. So batch Spark data already exists, and streaming Spark is like data keeps arriving. So historical data or any analytical data you want to process and generate the results. I mean, we'll use regular batch processing in Spark. Streaming in Spark is like structured streaming, we can call it as. Next, core building blocks are source, transformation, sync, trigger, checkpoint. Like check one by one. Source is like from where we are getting a data. Like for example, Kafka or any other files we are processing, or any other table updates immediately. I mean, whenever it is updated immediately, we need to pick up something like that. So the transformations part, like filter, select, group by window, and all those other similar functions, similar features we have already used in batch process. The same features we are gonna use in streaming process as well. Sync where results go, like console Kafka file table. So results will reach to a certain stage, we'll call it as sync, and then it will go to a corresponding target. So it's like a it's like one point to another point, the process completed, and it will go to the next process. So trigger means how often Spark processes new data. That is the trigger. Like every 3 seconds we need to trigger, or every 5 seconds we need to trigger again. I mean, whatever the data that is there available, you just pull up and process it and deliver it to the corresponding destination. So when it needs to be triggered, like at once, only one time per day or something like that. So it's like a schedule. Like, I mean, when we need to, how frequently, the frequency of the process, we can do it as trigger. And checkpoint stores process and progress, stores progress and state of a recovery, state for recovery. So the purpose of checkpoint is to, when there is a failure occurs, so if you reprocess again, it should not do from this, from initial point itself. So what happens is the results will be corrupted. So to avoid that thing, we'll use structured streaming. We will use checkpointing here. So most important mental model, structured streaming treats the stream like a unbounded table. Unbounded table as in, like, it keep on getting new rows, and it will keep on processing. It will just continuously processing. New rows keep getting appended over time. Okay. Sample example flow is Kafka or file source, and filter, select, aggregation, whatever the uh, transformations we need to do, and console file table sync. That's a sync. We just need to remember that in that way, and of course we'll experience that going forward and while processing further. So very important difference. Queries keep running. Spark process data in micro batches in most common mode. Like for a particular trigger you did for every 5 seconds, to the next 5 seconds, the trigger start again. In between that, we'll call it as a micro batch. that micro batch, like based on the trigger, it will generate each and every micro batch, and it will start processing set of the data, and it will generate the results. What does unbounded data mean in streaming? In your own words, okay? I'll try to explain. I'm using my Mac. I just want to cross check whether there was some slowness happening in in the Windows system, or maybe since it is an old system, but I want to check in this system now. So yeah, this is also taking time. I don't know why. Yeah, it's not coming. Okay. Yeah, now it is flowing. Okay. So unbounded data means the data that keep on coming into the corresponding source area and processing, and of course the next bunch of data come again. So maybe words I need to correct, I believe, but yeah, I'm submitting this result. Let's see if that able to explain, then we are good. That's correct. Okay. Refined, interview ready. No predefined size. No computation point. Pro 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 processed in ongoing micro batches. We'll remember in that way, like we process in ongoing micro batches that can be as an unbounded data. Okay, small upgrade for your answer is next bunch of data. Spark continuously process new incoming data in batches, micro batches. You cannot say bunches, you can say micro batches here. So example, Kafka topic receives events, log stream, sensor data never finishes. So yeah, it will start per day. Every day it will restart, and for example, if it's a Kafka topic, and every night it will restart, and after it will keep on getting the data. Whenever the trigger starts the Spark process, that will go to the particular source, and it will fetch the data whatever it is available at that time, and it just pull up the data and it will process all the computations whatever it needs to perform, and it will go to the corresponding sink, and then it will goes to the destination. So that's the way it will work. So this is the example types they have given, like Kafka topic receiving events or log events, sensor data, mm, so or any other type of data information they have given. So next, because data never ends, you cannot do normal group by like batch. So you need windowing plus state management. So these are the internal concepts of structured streaming now. So next concept is very important: append, update, and complete. I mean, the type of output modes in streaming is append, update, complete. So we'll learn step by step. Mm, guess plus think. There is a question here. Which would which mode would you use if you only want new incoming rows and never update old results? So it's definitely not an append, because existing results appended with the new records, that is a append, we call it as. And update means like existing data, if there is any correction or change or any additional things needs to be added to the particular data, that is called update. So it's the condition specifically mentioned update is not needed. So then it should be complete. Complete means the entire wipe out of the target data, and it'll load with the latest data whatever it is received. So I think I'll answer three, as we are not appending and updating. So I just eliminate those cases and I just gave the answer. But I think it may, yeah, good try, but this is incorrect. Let's fix clarity. Append. Correct answer is append. Okay. Why? Only new incoming rows. Didn't say only. Okay, newly. Okay, new incoming. Okay, there's a confusion here. Okay, sorry. Only new incoming rows. No updates. No updates to old data. So we need to understand these three modes now. So for that, the information is what each mode does. Append, only new rows added. Update, updated results. Complete, entire results table, every trigger. Okay. So why your answer is off? Okay, now I got it. Memory trick is like, append new data only, update change data, complete everything. So quick check. When would you use complete mode? Think in terms of aggregations, full results. What I want to say is, we'll use for while doing full results, since aggregation will have a dependency about a particular data, so that's why we are not using that. Let's answer this, and we'll see whether it is give great results or not. I mean, I'm not sure as of now, but let's see. Complete mode is used when you want to full aggregated results table, every trigger. Okay, in this case, yeah. So there is some gap here, like aggregations without watermark. When results keep changing for all groups, there is a confusion exactly happening. Let's see what it says. For example, group a DEPT count. Every new batch can change. Count for existing departs. So Spark outputs entire table again. Why not append here? So it didn't explain yet about watermark, but it is used that word, but I'm not sure why it is. But let's see. Every new batch can change counts for existing DEPTs. So Spark outputs entire table again. Why not append here? Because see, obviously it's not an append. It's definitely wants to new data. Old rows keep getting updated, not just new rows. So that's why we are not using append here. So yeah, Aggregation has a dependency. No, because aggregation updates previous results. Spark needs to output the full table. Let's go ahead further. Simple memory is append new rows only, update change rows only, and complete full table every time. Okay, quick check. Last for streaming basics. Okay. Uh, Running counts of events per user where counts keep updating. Obviously, I need to do update only. So let's see. Since that needs to be updated. So I will answer like this and we'll see. I think there is some clarity is missing, but even though it gave a basic information, but yet we need to go further about watermark concepts. Okay, before answering this question, I'll say that before answer before answering this. Before answering this, I want to know about watermark and detailed notes on structured streaming. Structured streaming. Let's see if it gives a brief information about the structured streamings. I think we can learn further and we can just review everything and go to the core concepts. Okay, great boss. This is the most important part of streaming. So let's build it. Clarity, no confusion. Okay, core concepts. Processing model. Processing model, like how it will process each based on the trigger, I believe. So it will be in micro batches. Each trigger will pull a micro batch and it will process them end to end. That we already aware. Next, the default mode is micro batch. Okay, outbound table concept, unbounded table concept, like stream infinite table, stream equals to infinite table, new rows keep getting added, so queries run continuously. So that is state. Very important is like on which state the current process is running on. Based on that only, it will, if there is any failure occurs, it will continue or it will may go from the starting itself. The commit of the particular data once the process is done, once the process is completed, so that's all depend on the state. So that's why uh, it's called stateful processing. So it will keep always an eye on the state of a particular process whenever it is running. So problem is infinite state without control. Data keeps coming, state keeps growing, memory issue. This I didn't understand. When you do group by user count, Spark must remember previous counts. Yeah, this is called stateful processing. Okay. So it says watermark is critical, but it didn't explain anything about it actually. So watermark is used to limit how long Spark keeps old data. Okay. Simple definition watermark. How late data is allowed to arrive. Okay. So the watermark will be a window. Maybe for example, in this case, if I give 1 minute, so it will wait to process that particular chunk of a micro batch till 1 minute, and whatever the records, whatever the data flow in that particular watermark window, it will consider and it will perform that operation. Like example, watermark event time 10 minutes. So 10 minutes, Spark will wait 10 minutes for the late data. After that, old data is discarded, because in real world events can arrive late, network delay, out of order data. So these are the main cases. I mean, why this is having a watermark concept. Okay, like visual timeline, like event time 10 arrives at 10.5, 10 arrives at 10.2, it's too late. 10.05 means 10 minutes 5 seconds, and something around at 10 minutes 20 seconds, so it's too late. So if it is within that particular window, what window I'm talking about, watermark window, then it will wait for that time, and after that it will consider pressing next. Windowing, very important, used with used with the time based aggregation, used with the time based aggregation. Df dot group by window event. Okay, so what it is window, very important. Okay, used with time based aggregation. Okay, what is time based aggregation? So window event time 10 minutes, it says 10 minutes of a window time it has. Count group data into time buckets. This I need to learn more. Time buckets, how it will work. Output modes, like obviously the same, append, update, complete. Full table refresh, you can say. Changed rows, only new rows. Okay. Checkpointing is critical, where progress offsets state. Fault tolerance and restart recovery. So for checkpointing is the main concept, where it'll, from that particular checkpoint onwards, it will restart again. Like means if there is any failure occurs in between, uh, if the process is re-triggered, then it will go to that particular checkpoint and it will complete it, and it will go to the next micro batch. So trigger controls how often Sparks process data. Okay, suspended operations, so supported operations is select, filter, stateless, stateful. There are two types of operations in the structured streaming: stateless, stateful. Select and filter is stateless example, and a stateful is group by window joins, because it needs to keep a particular group in a particular state so that it will compute correctly. So that's the best feature actually. Watermark deep understanding means without watermark, Spark keeps all past data forever. With watermark, Spark tracks max event time seen, drops old data beyond threshold. So this one I need to know little with example. Okay, so I need an example for the watermark understanding. So I'll ask the same. Key formula: watermark max event time seen delay. Max event time 1020, watermark 10 minutes, Spark keeps data after 10 onwards. Important rule: watermark works only with event time column, used with window aggregation, stream joins. Okay, handles late data. Watermark will handles late data, control state size, avoids memory explosion. So I'll say to the GPT now, I have a confusion, great confusion between state Okay, so let's first answer this question. If watermark equals to 10 minutes, a record arrived 20 minutes late, will it be processed? No, as watermark window is 10 minutes only. But after this explanation, I'll ask the question, like I have a confusion in. Yeah, records later than watermark threshold, so Spark discards it. Okay, watermark minimum allowed delay, within limit processed, beyond limit dropped. Okay, so but we still need examples, so I'll answer this question and I'll ask the question. I have give me some more examples. Okay, I'll ask that in an audio mode. This answer is processed. This will be processed, but I have a great confusion between watermark, checkpoint, state, and all those other stuff. So I just want to know with a clear examples and some more questions. I want to have an end-to-end understanding towards this concept because I am performing structured streaming in my next project. So I want detailed information so that I'll pursue this end-to-end. So I give this much data to the GPT. Let's see. Uh, So there is literally a slight confusion is there. Watermark execution and with example some. Okay, so perfect. This is exactly the right place to slow down and build a clear mental model. I'll make the end-to-end intuitive, not just definitions. Okay, yeah, that's very good. I think the best explanation it has given. Best picture first, most important. Think of structured streaming like this: incoming data processing memory is a state, output to saved progress is a checkpoint. Okay, where is the watermark here? Did I mention watermark in my watermark, checkpoint, state, and all those other stuff? So just want to know the the clear examples and some more questions. I want to have an end-to-end understanding towards this concept because I am performing structured streaming in my next project. Okay, so if that is the case, let's see state. Okay, uh, what is state? State equals to memory spark keeps across batches. That is a state. Okay, so the data will be saved in state or the where is the process, the whatever the triggered streaming process, where it is right now and what it is doing, that is stored in state. I'm not sure here, but yeah, let's go ahead and let's see if based on the explanation we may get some idea. Df group by user count. Spark must remember. Okay, user A count equals to 10, user B count equals to 5. So there is a group by user and each will have their own corresponding count, whatever the data, chunk of data or micro batch data, whatever it is received. So that micro batch data, it is the process currently doing end-to-end streaming. So it will save the state. Like for example, user A count 10, it will be saved in state. This memory equals to state. Okay, whatever wherever it is staring, wherever it is saving right now. Okay, problem. If data keeps coming, state keeps growing, memory explodes. Obviously, memory explodes. Watermark. Control state growth. What it does. Watermark tells Spark after this time, forget old data. So you do, but okay, I think we may need a detailed example here. Example df with watermark event time 10 minutes and group user and count. Okay, it is saying on a certain time period it is doing group by user, each group user how many records it's coming, it's just checking. Okay, Spark will keep data only within last 10 minutes, drop older data. Okay. So without watermark, state infinite. With watermark, state is controlled. Okay, I understood the use of a watermark. Checkpoint is processed offset, state, data, and progress. Like I think it's for fault tolerance only. Yeah, that's correct. Fault tolerance only. So okay. Now df dot write stream option checkpoint location, temporary checkpoint. Why needed? If job crashes, Spark starts from checkpoint, of course. No data loss. Okay. How they work together, very important. Yeah, that is the concept I want to know. Scenario, that's very good. Scenario is you are doing group by user and count. State keeps count per user. Yeah. Watermark removes old user events, prevents memory explosion. Just okay, watermark will help. Okay, now save state disk and enables recovery. Okay, this okay, we have a three differentiation clearly visible here. So keeps count, like for example the chunk of a micro batch it is considering, and it is doing a group by user and doing a count. State will keep the counts per user. Watermark will define a limit, like till this much time you need to wait, and after that you need to remove the relieve the old memory, since you already saved the state for each group, each user, each user group. Okay, so now the checkpoint is save the state to disk, so that if there is any failure happens, it enables the recovery from that particular standpoint. Okay, real time end to end example use case, count events per every 10 minutes, right? Mm, Example scenario. In this case, what happened here is df spark dot read stream dot format JSON load data. Okay, format is JSON and load from so and so location. Okay, result df with watermark event time 10 minutes, group by window event time comma 10 minutes comma user. Slash count. So it is capturing the event time for every 10 minutes. The window redefines for every 10 minutes, and it will group the user and it will start counting. Next, results. Result dot write stream output mode is update, format console, option checkpoint location. This is a checkpoint and it will start. So this okay, now I understood. Okay, so the last line is for writing the result, and there it is uh, giving an option of a checkpoint, because if this write is done, then one operation, one set of operation, one stream is done. So then it will go with the write trigger again, and it will start the next micro batch. So until this micro batch, if there is any failure occurs, the entire things will be relieved, and it will restart the process. Once we restart the process, it will automatically start from the beginning of that particular micro batch. Okay, so what happens step by step here? Data comes in, like for example, user A 10 1, user A 10 2. A state updates, A count equals to 2. Late data arrives 10.1. Within watermark will be accepted. Of course, it's out of watermark, then it won't accept, of course. Mm, Very late data arrives 10:25. Okay, that will be dropped. Okay, checkpoint saves current counts plus offsets. Okay, current counts plus offsets. Think of Spark like state notebook current counts. Watermark forget old pages after 10 minutes. Checkpoint backup copy of notebook. Okay, forget old pages from 10 after 10 minutes, of course. Backup copy of notebook. Yeah. So, okay. This is explained in a simple notebook manner. State is like a notebook and current count. And watermark forget old pages after 10 minutes. Checkpoint is backup copy of notebook. Yeah, that's very good. State store intermediate results. Watermark limits stage size. Checkpoint save state plus progress. Now I'll test your understanding. Okay. You have group by user count. If you do not use watermark, what will happen over time? Memory explode. That the answer is pretty straightforward, is memory explodes. If there is no watermark, the memory will explode. Let's wait for the answer. Yeah, sorry for the break. Yeah. So exactly, that's correct. Okay. Refined integrity. Without watermark, stage grows indefinitely. Memory usage keeps increasing. Can lead to out of memory failure. Okay. Okay. Why this happens? Connect the dots. Streaming unbounded data. Aggregation stateful. No watermark never evict whole data. If no watermark, old data will not be relieved, so it will memory explodes later. Aggregation is definitely stateful. Streaming unbounded data means it's continuously flowing data. Okay, next. So Spark keeps User A count forever, user B count forever. Key takeaway: watermark state cleanup mechanism. Yeah, it's like a garbage collection. Okay, let's deepen your understanding. Very important scenario. You have 10 minutes window, user 10 minutes window. You are counting the user, and will watermark actually help here? Is there a time based grouping? Can Spark know when data is old? Okay, 1 minute. Will watermark actually help here? I'll say, I think yes. Yes, it will help, as every 10 minutes the watermark limit, within the watermark limit, all the incoming data will be processed. So is it is a time based grouping. So after 10 minutes, whatever the data it is kept in the state, it will be relieved. Let's see. I think this is correct answer only. Let's see. Is there a time based grouping? Yes. Yes. Spark knows after 10 minutes the data is old. It's taking time. Oh my God, it's taking a lot of time. Uh, let's see. Stock- Let's see the answer. Let's refresh the window. Yeah, I think it's taking time. So yeah, it came. Still in that same area. It didn't progress any further. Okay, so before going further, let's review what we already learned. So instead of wasting time, so let's go back to the concepts again, and because it's literally crucial. So this is the main core area we need to understand. I mean, when you're performing streaming, otherwise it'll create unnecessary results. Okay, next step. So state is a the GPT gave an example like incoming data processing, memory is a state, and of course output and saved progress into checkpoint. Okay, so saving area will be the save will be the checkpoint responsibility. Okay, what is the state? State is a memory Spark keeps across batches. For each batch, whatever the memory it keeps, and to relieve that, we'll do watermark. So it needs to put a limit. We need to put a limit to a state. I mean, till what time it needs to keep the state. So for that purpose, we see state keeps growing, memory explodes. So to avoid that, we'll put watermark. So watermark will let the process know that you need to this is the time to relieve the space. Okay, after this time, forget old data. So that is the time it specifies, like for example 10 minutes. I mean, whatever comes under 10 minutes, it will perform that operation. And after that, after 10 minutes, the old data will be relieved, and of course next micro batch will follow the same set of a 10 minutes window. So yeah, without watermark, the state will be infinite, and with the watermark, state will be controlled, so that the memory explode should not happen. The checkpoint is like for the fault tolerance purpose. So when the process fails in between any stage or a state, so it will start from that particular triggering point, from that particular uh, checkpoint where it is failed. So the checkpoints, the purpose of the checkpoint is that mainly that. Next. So why needed? If job Spark restarts from checkpoint, of course, no data loss. Of course, how they work together. Gave an example like so infinite internally Spark does keep count per user, remove old user events, prevent memory explosion. Of course, obviously, when you remove old memory events, that memory will be evacuated, and of course it will be used for the next purpose. So that's why. And checkpoint save state to a disk enables recovery. That's the main thing. Real end-to-end example that we already discussed here. uh, for a particular Spark read stream, from it is reading from a certain location, which is a format as a JSON file, and after that uh, uh, DF watermark. 10 minutes is the window, and of course every 10 minutes the window will be restart automatically, and it will use this checkpoint to preserve the state, preserve the preserve fault tolerance, and if there is any failure occurs, it will start from that particular checkpoint. And what happens? Didn't answer yet. Let me refresh again. I don't know why it is stuck. Is there any gap or not? I'm not sure, but let me see. No, it's not going further. I think I'll end this session as of now. But whatever the learning we did till Spark streaming, I think that's a good learning we have. So the mainly state, watermark, checkpoint, these are the main key aspects. Of course, there are some other concepts as well, trigger and other concepts as well. So, but this is the main core concepts we need to understand. So as of now, I'm going to end this session. We'll continue the session further. Thank you so much.